Hello, good morning. We'll continue with the lectures on signals and systems. Myself, Dr. Shaila Dinkar Apte. This lecture is based on properties of LTI systems. Now, let us see which properties we are referring to. Here, we will be discussing the properties, namely the memory property, causality property, and the stability property. Firstly, consider memory property of LTI systems. Consider the impulse response of the system given by ht is equal to c into delta t. Here it contains only the sample at t equal to 0. That means it doesn't have any memory. So this is memoryless. Hn is equal to c into delta n. Here it contains only the sample at n equal to 0. This is also memoryless. So if the system has impulse response which contains only the scaled version of the impulse response, scaled version of the impulse, then the system is supposed to be memoryless. Otherwise, it will be with memory. Consider some examples. ht is e raised to minus mod t, ht is 3t u of t minus 1, ht u of t plus 2 minus t minus 1, ht is 5 delta t, ht is sin pi t into ut. So only this system which is given by ht is 5 into delta t contains only the scaled version of the impulse. Hence this particular system is memoryless. All others are with memory. Similarly, consider the discrete time systems. Hn is 2 raised to n u minus n u n minus 2. Here it is un minus 2. This is un minus 1. So this contains delta n. So this system is memoryless. All others are with memory. This also it contains delta n, but it also contains some other term. Next, consider the causality property of LTI systems. H of t is equal to 0 for t less than 0, then h of t minus tau is equal to 0 for tau greater than t. So for all tau greater than t, if it is equal to 0, then we say that it is the system is causal. That means the impulse response must be 0 for all t less than 0. Then it will be called as a causal system. Similarly, if Hn is 0 for all n less than 0, then it will be called as the causal system. So when I write the summation k varying from minus infinity to infinity in general, xk h of n minus k. But what is h of n minus k? H of n minus k will be equal to 0 for n minus k equal to 0, means n k greater than n. So here I'll have to write k is equal to minus infinity to n. Here also I'll write integration minus infinity to t for a causal system. Example 1. Consider that ht is equal to 0 for all t less than 0 and it exists for all t greater than 1, system will be causal. Second system exists for t minus 2 to 1 and hence it is non-causal. So we will go on analyzing all these systems. So this first particular system ut minus 1. So this is existing for all t greater than or equal to 1. So is the system causal? The system should be equal to ht should be equal to 0 for all t less than 0. This is true. So this e raised to 3t u of t minus 1 is causal. Now consider ht is u t plus 2 minus u of t minus 1. So it is existing from t equal to minus 2 to t equal to 1. So t equal to minus 2 it is existing, t equal to minus 1 it is existing. So this becomes non-causal. Now this is u of minus n, it is clearly non-causal. U of n minus 2, so it is existing for all n greater than or equal to 2, so this is causal. This is un minus 2, so it is existing between n equal to 0 to n equal to 2, hence it is causal. This is also causal, un minus 1, it is causal. This is un, so it is causal. This is delta n plus cos of pi n, so this becomes a non-causal type of system. Now consider the stability of LTI systems. The system will be said to be bounded input, bounded output, be both stable if and only if its impulse response is absolutely summable. So we'll have to prove this particular condition, that is, it is stable if the impulse response is absolutely summable, and then we'll have to prove this only if condition. So let us first prove the if condition. So consider that the input is bounded, and then we prove that the output will also be bounded. When we consider mod of xt less than or equal to m, we are considering that the input is bounded. Now what is yt? Yt is summation minus infinity to infinity h of tau x of t minus tau d tau. So we can write mod of yt as mod of minus infinity to infinity h tau x of t minus tau, which will be less than or equal to minus integration minus infinity to infinity mod of h tau into mod of x of t minus tau d tau, because the modulus of the product is less than or equal to the product of the moduli. So y mod of y of t will be equal to mod of integration minus infinity to infinity h of tau x of t minus tau. It will be less than or equal to m, because x of t is bounded, it is less than m. So in place of x of t minus tau, I can write capital M and integration minus infinity to infinity h tau d tau. So if this particular h of t is bounded, if impulse response is absolutely summable or if it is absolutely integrable, then y of t will be stable, because it will be finite in that case. Now consider one simple example. X of t is equal to h dash minus t upon mod of h of minus t for h t not equal to 0 equal to 0 otherwise. H dash is supposed to be the complex conjugate of ht. Now we are considering this particular xt, and for this input we will show that the system will be system output will be stable only if the input is bounded. Okay, so we'll consider the only if, proof of only if. So we are considering this particular input for that as the example. So consider y of 0. Y of 0 integration minus infinity to infinity ht x of t minus tau. Now t is equal to 0, so I am putting y equal to 0, so I am putting t equal to 0 here, d tau, t minus tau d tau. So in this case, x of 0 minus tau, I am putting this particular value for xt. So what is this? X dash tau upon mod of h of tau. This is xt. Now this ht into h dash tau is nothing but h tau square. So h tau square divided by h tau, which is less than or equal to minus infinity to infinity h tau. Now this is absolutely integrable only if h of tau is bounded. That means impulse response is bounded, otherwise not. Okay, and this will be tending to infinity for this particular input. This particular summation will tend to infinity because it is from minus infinity to infinity. So it will tend to infinity for this particular input xt. So we have proved only if condition, only if the corresponding output remains bounded for h of tau, means the impulse response being bounded. Consider one example. Consider the range of values of a for which hn is equal to a raised to n un is stable. So we are considering impulse response of the system as a raised to n un. Now the series will converge if mod a is less than 1. If the impulse response is absolutely summable or integrable, then the system will be stable. So this particular infinite summation should be convergent, it should be existing. In that case, it will be convergent only if mod A is less than 1. So mod A is less than 1 is the condition for the system to converge. Only under this condition it will be stable. Consider the examples of continuous time systems. So ht is e raised to minus mod tau. So I can write integration minus infinity to infinity ht dt is integration minus infinity to 0 and 0 to infinity. I am splitting the two integrations. So this will be 2 integration 0 to infinity e raised to minus t dt, because this, when I change the limit from 0 to infinity, e raised to minus t will become e raised to minus t. So it is twice e raised to minus t dt. So minus 2 e raised to minus t integration 0 to infinity. So it will be minus 2 into 0 minus 1 for t equal to infinity. E raised to minus infinity will be 0. So it will be equal to plus 2. Now h of t is e raised to 3t u of t minus 1. So integration minus infinity to infinity ht dt is equal to integration 1 to infinity e raised to 3t dt, e raised to 1 to infinity because u of t minus 1 is given. So what is the integration? 1 of 3, 1 by 3 e raised to 3t integration 1 to infinity. So if I just carry it out, it will be tending to infinity. So this is tending to infinity when t tends to infinity. So this tends to infinity. Now ht is u of t plus 1, t plus 2 minus u of t minus 1. So it exists from minus 2 to 1, minus 2 to 1 dt, and then plus 1 to infinity minus 1 dt. So this will be tending to 3, but 1 to infinity minus 1 dt will tend to minus infinity. So it will be tending to minus infinity. Then h of t is 5 into delta t. So it will be just 5 integration minus infinity to infinity delta t dt. So it will be equal to 5. So this is bounded, this is also bounded, but these two go unbounded, because the impulse response is not 0 for t less than 0. Examples of dt systems: hn is 2 raised to n u minus n, u of minus n. So it will be integration from minus infinity to 0, 2 raised to n. So it will be equal to 1 plus 1 by 2 plus 1 by 4, etc. And this infinite series. So we consider the closed form expression for this. So 1 upon 1 minus half, so it comes to 2, so it is finite, right? hn e raised to 3n u of n minus 2, u of n minus 2, that means it will be existing from 2 to infinity, e raised to 3n, so it will go to infinity. hn is equal to cos of 1 by 4 pi n un minus 2. So I can write it as integration 0 to 1 hn is equal to integration 0 to 1 cos of 1 by 4 pi n is equal to 1 plus cos of 1 by 4 pi n is 1 plus 1 by root 2. This is also finite because existing from un minus 2. So it is existing from n equal to 0 and n equal to 1. From n minus 2 means from 2 onwards it is equal to 0. Now consider the system interconnections. This diagram shows how the systems are interconnected. H1n and H2n, they are connected in parallel, so they are supposed to get add up. Then it should be getting convolved with H3n, and then you are supposed to add H4n to it. It is subtraction, so minus H4 of n. So how the interconnected system will function? Interconnected system will have the impulse response as H1n plus H2n. So when I consider H1n plus H2n, I will just have u of n plus 3. This un and minus un will cancel. Then I'll have to convolve it with delta n minus 3, and then I will have to subtract 1 by 3 raised to n un. So see how it will be. The overall impulse response will be h1n plus h2n convolved with h3n minus h4n, as we have just discussed. So just consider the summation of this. Un will cancel, so u of n plus 3 convolved with delta n minus 3 minus 1 by 3 raised to n un. But u of n plus 3 convolved with delta n minus 3. This is u of n plus 3. It is existing from minus 3 onwards. Delta n minus 3, it exists only at n equal to 3. And if you convolve, that is, you take the mirror image of this delta n minus 3, this corresponding impulse will exist only at n equal to minus 3. So at n equal to 0, it will be the multiplication of these two terms, so it is equal to 1. Then as you go on shifting this delta minus n plus 3, every time you will get the corresponding amplitude equal to 1. So the convolution output is nothing but un. So the convolution output is replaced by un minus 1 by 3 raised to n un. So it becomes 1 minus 1 by 3 raised to n un. So if I calculate it, how much it comes to, this is only some finite value, and it is existing only for un, that means it is existing from 0 to infinity. So this is the overall impulse response of the system. This is how you calculate the overall impulse response given the system interconnection.